Hello all. In this video, let's see about the attack known plain text ciphertext which is launched on Hill Cipher. Here the question is intercept the message FBRTLWUGATPHDNXSW which was encoded using a 3x3 Hill Cipher system. The last 9 letters are the sender's signature James Bond. Find the deciphering matrix and read the message. So in this particular question, we are given with a message in which it is given as the last 9 letters are nothing but the sender's signature, that is James Bond. So we could conclude that T corresponds to J, E corresponds to A, P corresponds to M, and so on up to W corresponds to D. Now we have to find the deciphering matrix, which means the decrypting key K inverse, and we have to read the original message, which means I have to find the original message for this particular ciphertext. So we know how to find and how to decrypt a ciphertext. The formula for doing that in Hill Cipher is P is equal to K inverse C mod M, right? So C is nothing but the given ciphertext. I have to find the plain text. So since the plain text for TEPHDNXW SW is given as James Bond, so here we know this corresponding plain text also. So from this we can find the K inverse first. So to find K inverse, the formula will be K inverse is equal to P into C inverse mod M. Now for plain text we will simply write James Bond. So K inverse is equal to, the plain text is James Bond, so JAM. It is given as 3x3 Hill Cipher system. So 3 rows and 3 columns. JAMESBOND. Now the ciphertext is so the corresponding ciphertext for this plain text should be written. Okay, the plain text which we are going to find is for F2A, but the known ciphertext for this plain text is from T to W. So we will write T E P H B N X S W, and please make sure that you write this inverse here, and then mod 26. Okay, now we'll write the numerical equivalents for these characters. So J corresponds to 9 and so on. The same way for the ciphertext, it is inverse mod 26. So now the first step is finding C inverse. So which is nothing but 1 by determinant of C into adjoint of C, but this can be expressed as mod M, right? So in order to find the inverse of C, first let us find determinant of C. So this can be found using calculator. So we'll be getting something around minus 1903. Since we're dealing with modular arithmetic, this is mod 26. Since this is negative, just neglect this negative symbol. So this gives 5. So again 5 mod 26, that is minus 5 plus 26, that is 21. So we have found that the determinant value is 21. Now the next step is to find the determinant inverse. For this we use Euclid's and extended Euclid's algorithm. So using Euclid's and extended Euclid's, we can simply write Q, A, B, R. This is for Euclid's algorithm. So the greatest number, so that is nothing but we are going to find 21 inverse mod 26. So 26, A goes to 26 and B holds 21. Quotient is 1, remainder is 5. So 21, 5, this is 4, 1, 5, 1, 5 ones are 5, remainder is 0, 1, 0, which means multiplicative inverse exists. Now let us go to extended Euclid's. T1, T2, T. T1 is initialized to 0, T2 is initialized to 1, we know that the formula T is equal to T1 minus Q times T2. So when applying this formula, T1, the value of T is minus 1, and T1 will hold the value of T2, T2 will hold the value of T, and new T value is 5, and this step is repeated again, and we get 5. So the multiplicative inverse of 21 mod 26 is nothing but 5. So we have found out determinant of C inverse. Now we have to find adjoint of C. Now let us find the adjoint of C using calculator. Go to mod matrix and just feed in the dimension of the matrix, which is 3 cross 3, and enter the values as 19, 7, 23, 4, 1, 18, 15, 13, 22. AC shift 4, and now go to matrix 1 and click X inverse. So this gives matrix inverse. Now multiply this with the determinant value, which is minus 1903. Note that you should multiply the determinant value without reducing it with mod 26. So this is the original determinant. We have to multiply C in, which means the matrix inverse into the original determinant, not the reduced one, and then click equal to. So we got. Now again we have to reduce it with mod 26. Now let us find C inverse. C inverse is determinant of C inverse into adjacent of C mod 26. So this is nothing but we have found that the determinant inverse is 5 into the adjoint is found to be minus 212, and then we reduce it with mod 26. So after multiplying 5 with the adjoint matrix, we'll be getting. So after reducing this with mod 26, we'll get 6. So this is C inverse. We have found out C inverse. Now we are going to substitute this in the formula K inverse is equal to P into C inverse mod M. Now let us find K inverse. So we know that the matrix P is 9, and we have found that the C inverse is mod 26. So just perform simple multiplication using the calculator. After reducing this with mod 26, we get this as the final matrix. So this is K inverse. Now we are going to substitute this K inverse into this main formula. Formula for finding plain text P is equal to K inverse into C mod 26. We have found that the K inverse is, and here the cipher text is nothing but the text from which we need to find the plain text. That was from F to A. So that is F. So the corresponding numerical positions are written now. Now after multiplying both the matrices and reducing it with mod 26, we will be getting 18. So this is the final matrix which corresponds to the original plain text. So 18 corresponds to S, 4 corresponds to E, 13 corresponds to N. So the plain text which we found was send roses, and the signature of the sender is James Bond. This was the original message that was sent. Hence, the known plaintext ciphertext attack can be launched on Hill cipher. since just knowing a small portion of this ciphertext, we could able to find the entire message. So this is how known plain text ciphertext works.